In this video, I'm going to show you a method called completing the square. This is yet another way to find the x-intercepts, or zeros, of a quadratic equation in the form ax squared plus bx plus c. We are going to work two examples in this video. And as a note, this method only works if a is equal to 1. If it is some other number, you need to divide all terms by that number to make it 1. Although factoring is probably still the best method for finding the zeros, or the x-intercepts, this is a very good method to use when you can't factor, such as this example, x squared plus 6x plus 1 equals 0. In this method, the first thing you want to do is get all the x terms on the same side and all the number terms on the other side. So you have x squared plus 6x equals negative 1. The next thing you want to do is take this term that's attached to just the x, and divide it by 2. That gives 3. Then you'll square this, and you'll put it here and here. You're going to add it to both sides. So you're going to add 9, and you're going to add 9 over here. So let me rewrite that so it looks a little better. You have x squared plus 6x plus 9 equals 8. Now, the reason we did this is because this part on the left side is actually a perfect square. It's x plus 3 squared. If you FOILed that back out, you would get x squared plus 6x plus 9. And that's equal to 8. At this step, we're going to follow what we've done in previous sections by taking the square root of both sides. So you have x plus 3 is equal to the positive or negative square root of 8. And of course, this can be broken down further. That's 2 times 2 times 2. So that's really plus minus 2, square root 2. And finally, you'll subtract this 3 to the other side. So you have x is equal to negative 3 plus 2 square root 2 and negative 3 minus 2 square root 2. Those are the two answers. Those are the two places where the parabola will cross the x-axis. Our second example is 3x squared plus 36x equals negative 42. This is already set up for us because it has the x's on one side of the equal sign and the number on the other side of the equal sign. As I said in the beginning, this method only works if a is equal to 1, which here it's equal to 3, so we need to divide everything by 3 in order to start this method. So we're going to have x squared plus 12x equals negative 14. Then, and I should have given myself a little more room. Let me change that. Should have given myself a little more room. There we go. Because we want to divide this by 2 to get 6, and then square it to add here and here. So we get plus 36. Plus 36. I'll clean it up a bit like I did before. X squared plus 12x plus 36 is equal to 22. Then, the reason we did this is because this is a perfect square. It's x plus 6 squared equals 22. At this point, it's just solving a problem from previous sections. Take the square root of both sides. That's x plus 6 is equal to plus or minus square root 22. And if you want to know if you can simplify that further, remember that's 2 times 11. Both of those are prime. You can't bring anything out. So our final answers are x equals negative 6 plus square root 22 and negative 6 minus square root 22. It doesn't matter if you write it like this or negative 6 plus minus square root 22.